So this video is going to cover the metric system units. Learning target is I know the metric system units, prefixes, and can convert between metric units. So you should be able to confidently say that statement by the time we get done with this lesson. So if you're looking at this speedometer, you might notice a couple of things. You might notice that this guy must have a little bit of a need for speed. Speedometer goes up to 220. So hopefully he's not driving down the roads like that. You also might notice that there's a couple different little measurements on here, km-h. If you don't know what that means kilometers per hour. So this is not a typical mph. This is measured in kilometers per hour, which is a little bit different from what we do here in the United States. Now this map is actually a map of all of the countries in the world, the ones in red, that do not use the metric system. So the United States is one of those countries. We measure in miles per hour. Other countries in the world will measure in kilometers per hour. They might measure in grams. They might measure in liters. We don't measure that way. So with all of these differences in the world, with the way that people measure and us kind of sticking to our guns on the English system, we have to have a way of measuring across science and something that we can communicate with scientists over in, let's say, Europe, right? Or maybe scientists in Australia. Right? How are we going to communicate back and forth? So scientists came up with something called the International System of Units, the SI units. And these are going to be the internationally accepted system of measurements so that when we talk to someone in Australia, we know when we say meters that they're also going to say meters. Right? Or when we say grams, they're also going to use grams. And so we don't have to constantly convert between pounds and kilograms or feet and meters. We know that these are the measurements that we need to use in order to communicate with other scientists across the world, to share our findings and to collaborate with them. And so the units that we're going to use in science in this class, the ones that I really want you to know here at the beginning part of this class, to measure in time we're going to use seconds, to measure in distance we're going to use meters, to measure in mass we're going to use grams, and to measure in volume we're going to use liters. So hopefully these aren't completely foreign to you and you've had some experience with them. Obviously time with seconds, you should feel pretty comfortable with that. With distance in meters, you should maybe, maybe you've noticed that the 100 yards on the football field is a little bit shorter than the 100 meters on the straightaway of the track when they're right next to each other. That's because meters and yards is the difference between metric and English. Yards is an English system unit and meters is a metric system unit. When we look at mass and grams, you've probably heard of kilograms before, but we use pounds a lot in the United States. And when we measure volume, you've probably seen a 2-liter bottle of pop. That's the way that I always think about it. Is a 2-liter bottle of Mountain Dew is a lot of pop. And so we will sometimes use some of these metric systems, but a lot of times we'll use a 16-ounce bottle of pop, right? So these are the units that we're going to use in science. And when we make measurements in science, these are the ways that we're going to make these measurements. And so today it's all about recognizing how these units are represented and how we can convert between different forms of these metric system units. Ways that we can represent these, and you've probably seen this before, with seconds we can just write an S. With distance we can write a M. With mass, grams, we can write a G. And with volume you're going to see this capital L right here to represent liters. This is just a shorthand way of us showing these units. So if I said 10 seconds, I would write 10S. And if I write, let's say 5 meters, I would go 5M. So that's what you're going to see with those measurements. Now with each of these measurements, we can also adjust that measurement, and we can put a prefix in front of that measurement, that unit, to show a different number than just the base unit. Just like in the English language, if I wanted to, maybe I wanted to do something, right? Well, I can change that word by putting the prefix of un in front of it, and that means a completely different thing. To do means to get something done, and to undo means to take something apart, right? Or maybe I wanted to redo something. I've already done it once, so I wanted to go back and do it again. And so we can change our language in the English language by putting a prefix at the start of our words, and we can do the exact same thing with our measurements. If I have a gram, and I wanted to change that gram, I could just simply put a kilogram. That's a completely different thing. What I'm saying then is I have, kilo is the prefix, I have 1,000 grams. I'm saying I have a lot more grams. It's like I was saying redo, kilogram. And I can also represent it this way. Remember, grams could be represented like this. I can also represent a kilogram as a kg. See, the abbreviation goes right here. So that would go right up in front. If you're comfortable with scientific notation, these are the powers that would go to. So a kilogram would equal 10 raised to the third grams, or 1,000 grams, just another way of representing that. Scientific notation can also save us a lot of space when we get up into really big or really small numbers. And so these prefixes are just ways of adjusting our base measurements that we make. Okay, it's another way for us scientists to communicate with each other a lot more efficiently, so we don't have to write out so many things. To write out a kilogram would be a lot of space. And so when we have these, the good thing about these prefixes is that, as you can notice, our base unit fits right into here. And we multiply by 10 to get up to the next one, the deca, and we multiply by 10 to get up to hecto, and we multiply by 10 to get up to the kilo. And so really, if you remember what multiplying by 10 does, as we're converting from, let's say, a kilogram to a milligram, we can just move the decimal place of our number in order to change these over, because they're all multiples of 10. Remember, multiples of 10, we can just move that decimal place. And so, for example, if I had 1,000 kilograms and I wanted to know how many milligrams that would be 1,000, 1,000,000 milligrams. Okay, I'm going to show you how to do that in the next slide. Little opening. So as you can see here, I've laid out these prefixes in a row from each other. And the way that my high school science, or my middle school math teacher taught me how to do this was, we remember that K, H, D, U for our regular unit, deci, D, C, M. Remember, it comes into that order because of this mnemonic. We have Kenny hunts deer until dumb cows moo. Kenny's out there hunting deer until these cows come by and they moo, and then he's done hunting because the deer aren't going to come in anymore. So Kenny hunts deer until dumb cows moo. And you can find other mnemonics online if you wanted to look some other ones up. There's some pretty funny ones out there. But this is going to help us to convert between our metric system units. So let's say I had, like in the last example, actually let's start with a different one. Let's say I had 1 kilogram. Let's say I had 1 kilogram here. So we've got 1 kg, and I want to know how many grams that is. And so, because these are all multiples of 10 of each other, we're just moving the decimal place on these numbers. And so if I start down here at kilograms, I can see that my base unit of grams, right here, is 1, 2, 3 spots over to the right from where kilo's at. And so as I'm writing 1 kilogram, let's say 1 for my grams, my decimal point is right here, and I'm going to move it over 3 spots to the right. 1, 2, 3. I'm going to draw my little kind of arrow and put my decimal place down there, my new decimal point, and I'm going to fill in these open spots with zeros. And then I'm going to add my units down here at the end. So what I have here is 1 kilogram is equal to 1,000 grams. I moved my decimal place over 3 spots to the right and then added zeros into there. And this is going to help us out to be able to convert between all of these units. Right? The one that I did before was from kilograms over to milligrams. And so if I'm moving over that far, I'm just going to add more zeros into there. Let's go the opposite way. Let's go from milligrams. Let's say I have 10 milligrams, and I want to move over into, I don't know, let's go to kilograms. So I start with my 10, my milligrams, my milli is right down here. I'm going 1, 2, 3, 4, 5, 6 places over to kilo. So I'm going to give myself some space here, and I move 6 spaces over to the left. My decimal place in my milligram is right here, my 10, and I'm going 1, 2, 3, 4, 5, 6 places here. My decimal point is there. And now each of these openings, I'm going to add in a 0. 1, 2, 3, 4. Right, so now I can add that on there. And so now I know that if I have 10 milligrams, that is going to equal, I'm going to write it down here just for space, 1, 2, 3, 4, 1, 0 kilograms. And this makes sense because we know that a milligram is much, much smaller than a kilogram. So to have 10 milligrams would be a very, very small number of kilograms. But once you get the hang of this converting units and metric, you know that we're just moving the decimal place, and it actually becomes a pretty simple procedure, whether you're going bigger or smaller. And with all of these prefixes, the three that I really want you to know for science, the ones that we're really going to use a lot in this first unit especially, is kilo, centi, and milli. And so knowing that your kilogram is 1,000 grams, this conversion factor right here, knowing that your centigram, there's 100 centimeters in a meter, and knowing that your milli is 1,000 of your liters, knowing that that's the smaller one, is going to be really important as we go through physical science. So those are the ones that I'm hoping that you use them enough where you just memorize them. The two numbers you need to remember is 1,000 and 100. And you need to remember that a centimeter is 100 meters. And so that's how you can remember your centi. And then remembering that milli is very, very small using the number 1,000. And knowing that kilo is very, very big using the number 1,000 should help you out with that. You know that 1 kilogram is 1,000 grams, and 1,000 milliliters is 1 liter. And so, like I said, by the time this lesson is over, that you should be able to know these metric system units, the meters, the grams, the seconds, and the liters, and know the prefixes, and then be able to convert between these metric system units.